This video is based on the comparison between two meta-heuristic algorithms. In this video, we will try to understand how we can compare two meta-heuristic optimization algorithms. For example, you can see here we have particle swarm optimization algorithm and Jaya optimization algorithm. The comparison between these two algorithms is done using the standard test functions. First, you can see we have the particle swarm optimization algorithm. Particle swarm optimization algorithm is simple algorithm with few parameters. This algorithm mimics the social behavior of birds flocking, where a group of birds are randomly flying and they are searching for the food in the area, and it is assumed that there is only one piece of food, and the PSO search strategy, follow the bird that is nearest to the food. On the other hand, we have the Jaya optimization algorithm. Here the inspiration for this algorithm is survival of the fittest. Jaya optimization algorithm is also a simple, unique but powerful optimization algorithm. It is a gradient-free optimization algorithm, and it is also simpler than teaching learning-based optimization algorithm. In the Jaya optimization algorithm, once the best solution is obtained, it avoids the worst solution, and we can use this algorithm to solve the constrained and unconstrained problems. Now you can see the application areas where we can use these algorithms. PSO and Jaya algorithm both have population-based meta-heuristic optimization algorithms. We can use PSO in the signal processing, networking, antenna design, fuzzy systems, robotics, graphics, data mining, and in other areas. And we can use Jaya optimization algorithm in the image processing, feature selection, economic dispatch, planning and scheduling problems to solve planning and scheduling problems and other. So here you can see these are the application areas where we can use these algorithms. Now question is, which algorithm is better? How we can check that PSO is better than Jaya optimization algorithm, or Jaya optimization is better than PSO algorithm? Now we will try to understand how we can compare two meta-heuristics. All the basic details, mathematical models, flowcharts, algorithm steps, and the numerical examples we already discussed. You can check the link given below in the description box or in the comment section. Right now we will try to understand the comparison between these two algorithms. Here the comparison between two meta-heuristics is done using the standard test functions. Standard test functions such as unimodal test functions, multimodal test functions, and fixed dimension test function. So we are using the standard test functions to verify the effectiveness and flexibility of these two meta-heuristic optimization algorithms. First, we have the unimodal test function. Unimodal test function reflects the good convergence property and the exploitation capability of any meta-heuristic algorithms. So we can check the exploitation capability and the convergence of any meta-heuristic using unimodal functions. And in the unimodal test functions, the fitness curves represent the algorithm convergence speed. Second, you can see we have the multimodal test functions. Multimodal test functions are used to test the local search and global search ability of any meta-heuristic algorithm. We can say any algorithm is successful when there is a balance between the local search and global search, that is the exploitation phase and the exploration phase. So here we can use the multimodal test functions to check the local search and the global search ability of any meta-heuristic algorithm, and we can also analyze the algorithm stability, convergence speed, and convergence accuracy. And the last one, we have fixed dimension test function. Fixed dimension test functions are used for the verification purpose. Fixed dimension test functions are used for the verification. We can verify the algorithm stability, convergence speed, and accuracy. So here we are using the standard test functions for the algorithm comparison. In this video we use 3 standard test function for the comparison between particle swarm optimization algorithm and Jaya optimization algorithm. In this video we are using the 3 standard test function to verify the effectiveness, flexibility and the performance of any meta heuristic of particle swarm optimization algorithm and Jaya optimization algorithm. First function f1, you can see here this one, it is multi-model test function. Second function you can see here f2, that is unimodal test function. Third function you can see here this one, it is multi-model test function. So we used here just 3 test function to check algorithm performance. So using these test functions we will analyze the algorithm stability, convergence speed and accuracy. Now you can see here we have the testing parameters that are used for the comparison, and they are same for both algorithms. Population size, that is the total number of individuals in the current population. Dimensions, it means the total number of design variables. Maximum iterations, that is the total number of generations. Total runs, here how many times we will run the algorithm, and in the end we will obtain the optimal value and the convergence speed. Optimal value is the minimum value among all, and the convergence speed means the computation time that is taken by the algorithm. Population size, you can see here the values for the parameters. Population size we have here 50, dimensions 4, maximum number of iteration 100, and we used 5 independent run for each algorithm. So here you can see the output values for PSO and J algorithm. You can see the values for the PSO, values for J algorithm for the first function, for the second function and for third function, and we used here 5 independent run, and you can see the optimal value for these algorithms. Now for the first function you can see here the value for PSO in the first run we have 1.55, for Jaya we have 1.03, and here you can see right now Jaya algorithm value is better as compared to PSO. In the second run you can see PSO value is 1.28 and Jaya value is 1.15. Again Jaya optimization algorithm value is better. And now you can see here in the third run for PSO 3.09, and here we have 1.06. Again the value for J algorithm is better. In the fourth run you can see the value for PSO is little bit improved, that is 1.01, but this time you can see the value for J is again improved, and this is 0.69. And here again in the fifth run the value for PSO now you can see 1.59, and here we have 1.68. PSO algorithm do not guarantee an optimal solution. PSO algorithm require large memory, and due to its premature convergence you can see here this algorithm easily stuck into the local optima. You can see the values change here. Due to the premature convergence, this algorithm easily trapped in the local optima. Right now you can see for the first function among all we obtained the best value for PSO in fourth run, that is 1.0142, and for J algorithm we obtained the best value in the fourth run. Now for the second function you can see the value we obtained for PSO is 3.8, and here we obtained 1.3. Again value for J algorithm is better as compared to PSO. Again in the second run we obtained the value for the PSO 4.93, and for J algorithm 2.88. Again, the value for J algorithm is better as compared to PSO. Again, you can see here, due to the premature convergence, PSO is easily trapped in the local optima. And here you can see for the second function, value in the third run, fourth run, and in the fifth run, and among all you can see we obtain the best value for PSO in the fifth run, and we obtain the best value for J in the first run. Now you can see for the third function we obtain the value for PSO in the first run 0.0049, and here for J 0.028. In the second run, again you can see 0.0024 for PSO, and again the value for J is better, 0.012. Now you can see the value for PSO is repeating. It means this is the optimal value for this algorithm. Now you can see we used here only 5 independent runs for each algorithm. So how we will decide that when we will obtain the optimal value? For example, you can see here for PSO the value is repeating 0.0024. In the third run again it is 0.0024, and now this value is repeating. It means this is the optimal value for PSO for the third function. And you can see among all the optimal value we obtained for PSO in the second run, and we obtained the optimal value for J algorithm in the third run or in the first run. Now you can see the computation time for both algorithm. For the first function, PSO computation time is 3.742, and J algorithm computation time is 2.7273, and again J optimization algorithm computation time is better as compared to PSO. For the second function, the computation time for PSO is 3.9019, and for J algorithm it is 2.9943. Again, for the second function, J algorithm computation time is better as compared to PSO. And for the third function, the computation time for PSO is 4.1026, and the computation time for J algorithm is 3.5674. Again, the computation time for J algorithm is better as compared to PSO. PSO algorithm require large memory, and in PSO the balance between the exploration and exploitation phase is maintained using the Bate inertia factor. You can see when we will compare PSO and J algorithm is better as compared to PSO algorithm. You can see for the simplicity we use just 3 standard test functions and 5 independent runs for each algorithm. You can increment the number of standard test functions for better quality solution, and you can compare 3, 4 or many more algorithms, and you can increment the number of test functions and number of runs. So that's all about this video. If you have any question, you can comment below, and thanks for watching this video.